kick things off, I start by copying the build and workspace files from the demo project into the gRPC-Haskell folder. Let's see if Gazelle will run. It says I'm missing something from the root cabal file, but everything seems to be in order there. Let's check out the Gazelle cabal docs. I see that there's no mention of C2HS support. Maybe they don't support CHS targets. I tried a few things, but ultimately decided to just rename the CHS files to HS files. Gazelle cabal doesn't actually seem to care about the contents of the files, so this should be enough to trick it into generating a build file that I can tweak. Okay, Gazelle ran successfully. Let's try to see what we'll build. I'm expecting an error about the CHS files. But instead I get an error about an invalid package name. It looks like Gazelle created an invalid Bazel layout. We could try to fix that by reorganizing the build files. Let's move the test directory and other subdirectories to their own Bazel package. There's no reason Bazel packages need to line up with Haskell libraries in the cabal file. We'll also move the bench targets to their own Bazel package. Having each folder be its own package is more standard than having a build file with targets in nested subdirectories. Curious what this version number is doing as a GHC option in the benchmark target. Ordinarily, something like a version number seems like something that's not target specific, and certainly not specific to a benchmark target. At any rate, it seems like we want to avoid having per target compiler configuration if we can. My guess is Gazelle just copied it from the cabal file, and perhaps it's common to set compiler options on a per target basis there. Oops, I need to fix up the imports for the new build files. I'm getting a name conflict with some Go tests. I plan on redoing the tests anyway, so I'm just going to delete these targets for now. Now I'm getting an error that it can't find a package called managed. I've never heard of this package, but the error seems to suggest that it may be in Stackage. Gazelle has support for generating the workspace file, and Gazelle Cabal seems to support this. So I'll try that. Hopefully Gazelle Cabal can find the managed package for me. First I need to create a target for updating the repo. Then we run the target. That seems to have been successful. Let's see if our workspace file was updated. Looks like we got a lot of new stack snapshot dependencies, which is promising. Let's see if it builds now. Nope, Bazel can't find a package called Proto3 Suite, although it's listed in the stack snapshot. The error says the impossible happened, which suggests that this code is supposed to be unreachable and hence only execute for a serious bug. It appears that it's from stack, and maybe they're just trying to be cute. I'm not sure if failure to find a dependency counts as a critical bug. It turns out stack can work with non-stack dependencies as long as you explicitly specify a version number. So let's do that. Now the build is failing because it can't find zlib. It's not declared as a dependency in the cabal file. It must be a transitive dependency. We see that the gRPC-Haskell build gets zlib from the ambient environment. It's a system library provided by Nix. It turns out the zlib dependency comes from a package called turtle. I see they're importing the Haskell zlib package, but the code doesn't mention a zlib dependency. It must be a hidden dependency. Fortunately, Stack Overflow tells me there's a Bazel library for working with dependencies that are foreign to the Bazel ecosystem. Copyright is Google Inc. So even though this isn't an official Google project, it still looks like it's developed by Googlers. So the quality is probably pretty strong. Ooh, a design doc. That's a great sign. Let's start by copying some zlib config from the rules Haskell people. Rules Haskell gets zlib from Nix, but I want to remove the dependency on Nix. So we'll get it from rules foreign. Let's start by copying the configuration from the rules foreign site. It's just creating a file group for the entire zlib archive and creating a runtime build file for it. The build config invokes CMake, which is a Bazel rules foreign rule for interfacing with CMake builds. Okay, that was successful. We can now build zlib from rules foreign. We just need to make it a dependency of the stack snapshot. Now we're getting a new unexpected error, which is that Bazel can't find the gRPC header file. The gRPC-Haskell repo made gRPC available as a system header, so it wasn't available in the build system. We could try to do the same by installing the development headers with the Debian package system. That would be brittle, and it's unlikely that Debian has the exact version of gRPC that Bazel is expecting. Fortunately, gRPC is built with Bazel, so in theory it should be straightforward to add it. However, gRPC's build system is a little complicated and custom, so if rules Haskell hasn't been tested with it, it may take some work to integrate. Go ahead and add a CC library target for the gRPC cbit stuff. This isn't a target for the gRPC C code itself, it's a target for the gRPC Haskell C bindings. As expected, we're getting an error that the gRPC header can't be found when we're trying to build the gRPC Haskell C interface code. The obvious thing is to try to make this interface depend explicitly on Google's gRPC Bazel target. That fails with some error about the Apple ecosystem. I'm not on Apple, so this seems like a bug. Some dependency is misconfigured and is trying to build targets that aren't suitable for the host or target platforms, which are both Linux in my case. I'm not going to root cause the issue, I'll just try upgrading the gRPC version to a more recent one. Maybe it will go away. I tell Bazel that I want the latest gRPC. This is version 1.55. This is much more recent than version 1.34, which is what the gRPC Haskell cabal file asked for. gRPC Haskell's README says this is the only supported version, so using the more recent gRPC version might cause an issue down the line. We'll see. Most likely, if it compiles at all, then things will work. Now I'm getting an error about registering Go toolchains. It looks like someone is trying to set the Go version after it's already been set. Let's check the gRPC GitHub issues. It looks like there are a few issues mentioning this error. I'm not going to root cause the issue, I'll just try upgrading the gRPC version to a more recent one. Maybe it will go away. This seems like the most complete bug report. It's a request to let the user call go register toolchains. Apparently gRPC calls this function, and that removes the user's ability to call it, since it can only be called once. The fix seems to be blocked on a Starlark issue. I'm not sure exactly what that is, but it's enough information for me to decide that this is a rabbit hole, and I'm better off just reorganizing my workspace file to work around the issue. Okay, that should do it. Alright, now Golang is happy, but the build is failing because we can't find the gRPC Haskell.h header. The header exists, so why can't it be found? Oh, it turns out gRPC Haskell is importing the header as a system library. It can find the header now. Let's try uncommenting everything in building. gRPC cbits now built successfully, so that's good. Let's try building all of gRPC-Haskell core. Unsurprisingly, it's still failing to find the grpc.h header. Now I'm getting the generate cabal paths module error I got before. I can work around this by using the rules Haskell repo from head instead of the latest release. It can't find some modules. I recognize these as the CHS modules I renamed, so I think it's time to try to configure C2HS. First, let's see if rules Haskell is anything like a C2HS library rule. Looks like they do. That's good news. And let's undo the renaming so I can get the CHS files back. Maggot, the Emacs Git interface, makes this pretty easy. Now we need to change the file extensions in the build file to match the actual files. And let's try to build. And I'm getting a new error. It seems like Haskell library rule doesn't like the CHS files. That's understandable. Let's wrap them in C2HS library rules. We're getting another import error. I think I need to make the Haskell library depend on the C2HS library target. Now Bazel is complaining that I don't have a toolchain set up for C2HS. I'll go ahead and set that up. After some debugging, that seems to be set up correctly. Now we're getting an error that Bazel can't find libaries. Aries is a DNS library used by gRPC. Isn't another hidden dependency like zlib? Because I saw build configurations for Aries in the gRPC repo. Seems like it might be a bug. It may take a bit to dig into it,